Hi students, next up we're looking at trigonometry in a circle. What we're going to do is take those reference angles that we've been playing with and kind of see what happens with those. So if we're given some kind of an angle, I don't know, let's say 135 degrees or 3 pi over 4, what we can do is take a look at the reference angle here, and that would be a reference angle of either 45 or pi over 4, depending on if we're in degrees or radians, and do some trig with this triangle. And if I know some information here, like the size of the hypotenuse, or the x or the y, I could figure out the rest of this triangle without too much trouble. We're going to go into how to do this today, and a way to make this a lot easier for us to find these values with by setting our radius for the circle equal to 1. When we do that, that's called a unit circle. So we're trying to find unknown things, and we are setting the radius of these equal to 1 so that every hypotenuse around the circle is going to be the radius is also going to be equal to 1. We're going to use some trigonometry to find some unknown sides here. And because I'm asking you to use right triangle trig, I probably will ignore the fact that these are special right triangles for now and deal with this in terms of the trig of this. Okay, so if I'm looking at my first triangle, 45 degrees, I know that we've got an opposite, we've got an adjacent, and the hypotenuse. Hypotenuse is 1, and to try to find, let's say, y, we can say that this is sine of 45 degrees is equal to y over 1. That's actually kind of interesting, because I know that that's just the same thing as y, and whatever this y value here is, that's going to be my same value as the trig thing. Sine of 45 comes out to be 0.707, and that's going to be our y coordinate here. This also introduces something really important for us, where the sine of an angle is going to be equal to the y value of the coordinate on a unit circle. All right, how about the x? That's adjacent over hypotenuse, so cosine of 45 is going to be x over 1, and the same thing's going to happen. Leave me with just cosine of 45 is equal to x. Cosine of 45 is 0.707. And if you notice that these are the same value, this is a 45, 45, 90 right triangle. And these values actually happen to be the square root of 2 over 2 and the square root of 2 over 2. You might remember that in 45, 45, 90s, we have square roots of 2 that show up, and also that this is isosceles, so those should be the same number. Looking at our next triangle, we've got 210. To find this reference angle, I've got to figure out how much past 180 this is, and that's going to be 30 degrees. So we got a 30, 60, 90 triangle here. But again, I'm not really trying to figure out what's going on here in terms of those exact numbers, so I'm not so worried about this for the special right triangle. I am very interested in how to find these things. Same thing maybe for sine of 30, and that's going to be the length of y over 1. We end up getting 0.5 for that. The only thing I want you to be aware of is that down here, this is going to be at negative 0.5 for a y coordinate, because we are below the x-axis. So the sine of 210 is going to end up being negative 0.5 for that reason. All right, then the other one, cosine of 210 or cosine of 30 is going to be the x here over 1. And when we do that, we're going to get 0.866. I'd also like you to notice that the x here is in the left side, so that coordinates are going to be negative 0.866. In terms of radicals, this would be the square root of 3 over 2, and this would be a half. You might recognize the square root of 3 comes into play because we have a 30, 60, 90 right triangle, and that happens a lot here. In all of the trig that we're going to do, we're going to use the same type of process, but we're going to have something called a unit circle for us to use as a reference, which we're going to see on the next page. Okay, so we've got a unit circle reference to use as a tool. And what I'd like us to do is to think about that last triangle that we had. So that was looking at 210 degrees, and we had this triangle here. This is in radians, so I'm going to convert this to radians. It's going to be 7 pi over 6 radians instead. And that would make us have a reference angle of pi over 6. We mentioned in the last page that sine of an angle in a unit circle is equal to the y-coordinate, and we said that cosine of an angle in a unit circle is the x-coordinate. The third thing we're going to talk about is the tangent, which is opposite divided by the adjacent, would be the y over the x. When we're using a unit circle as a tool, what we're going to do is to find that reference angle and think about these coordinates. So for our reference angle, the point, this is labeled as p of pi over 6. This is our reference triangle. We're given root 3 over 2 and a half as our two values. That means that my x value is root 3 over 2. I don't know why the root 3 didn't show. There we go. And the y value is going to be a half. Okay. So the first thing we need to do is to figure out what those reference values are. And we just did. The sine of that would be the y value, which would be a half. The cosine of that would be the x value, which would be root 3 over 2. The tangent of that would end up being the y divided by the x. So it would be 1/2 divided by root 3 over 2. I'm not going to worry about simplifying that right now. So I'm going to call that finding our reference values. Reference. The second step is to find our quadrant, and we're going to use that to decide whether this should be positive or negative. For the angle we're looking at, we're in quadrant 3, and since our x is less than 0 here and our y is less than 0 here, we're going to make some changes to these. So sine of that angle is going to be negative a half. Cosine of that angle is going to be negative root 3 over 2. And for tangent, both of these are going to end up being negative, which ends up canceling those things out. So if we divide a negative by a negative, that's a positive. We get a half, and then times 2 over the square root of 3. Those 2's cancel out. I'm left with 1 over the square root of 3 for tangent. Let's look at how we might apply this to a specific problem. All right, so we're trying to find the exact value of each trig function, and one of the things I'd like you to notice is that I gave you a full unit circle this time. In looking at this, one of the things we could literally do for like 7 pi over 4 is find 7 pi over 4 on here. Okay, that's down here. Cosine of an angle is the x value. The x value here is root 2 over 2. At this point, that problem is done. That's the exact value of that trig function at that point. If I'm asking you for an exact value, it needs to be given in this way, not as a decimal. The next one we're looking at is sine of pi over 3. We're given a full unit circle, so I'm going to find pi over 3 on here. All right, that's going to be the y value. And here the y value is the square root of 3 over 2. All right, then we're finding cosecant. I know that cosecant is the same as the reciprocal of sine, because the opposite letters go with each other. So what I'm going to do is find sine of 330 first, and then I'm going to find the reciprocal of that. The other issue that I have here is that we're dealing in radians, so I've got to do a quick conversion just so I can see what's on my unit circle for that. And when I do that, we end up getting 11 pi over 6. Okay, so I know this is the y value at 11 pi over 6. That's going to be negative a half. The reciprocal of that, so 330, is going to be negative 2 over 1. At this point, that problem is done. For cotangent, we're going to do the same thing. This is based on the tangent of 9 pi over 4. We're going to have another issue here. That's not on my circle, so I've got to think that this is going to be, okay, that's 8 pi over 4 because that's 2 pi. I'm going to go 1 extra pi over 4 and end up here. So there's my 9 pi over 4. And tangent we know is y divided by x. Here that would be, oh, those are the same numbers. So in this case, that would be 1. And then the reciprocal of 1 would still be 1. So the cotangent of 9 pi over 4 is 1. Here we've got some with some negative values. Negative 180. I've got to go in this direction to get to my 180. And my points here are going to be negative 1, 0. We're going to do a little bit of a shortcut here. So if tangent is y divided by x, cotangent is x divided by y. The reason that we did that shortcut is just so we can kind of get some of these a little bit in our heads as we're kind of working through this. And that's a good one so that we don't have to always do reciprocals. In this case, we get negative 1 over 0, which is undefined. Cotangent does not exist for that value. Sine of negative 5 pi over 3. We have a couple different ways that we can look at this. One is figuring out what that means. We know that 6 pi over 3 would be the same as 2 pi. This is going to be pretty close to that, but a negative direction. So we're going around like, okay, there's 1, 2, 3, 4, 5 pi's over 3. Another way of us looking at this is to find 5 pi over 3 and flip it over the axis. Because that's going to be the opposite direction of which way, whatever way we're going. So if that's down here, that flips up to up here. That's one way to look at this as well. Sine is going to be the y value. The y value here is going to be root 3 over 2. The takeaways from this are always going to be to figure out the reference value and then figure out the quadrant and the sign. That will always work for finding unit circle trig values.